All right, so I'm not sure you can read the numbers. I'll try again here. The initial burette reading was 0.00. Don't forget to have a label here, milliliters. Our final volume in the base burette, this is the NaOH, was 18.30. Trial 2, we started at 18.30 and we went to 42.50. Please make sure you have your data out to the hundredths because that was what we used. We had burette and you can read to the tenths, so you estimate that last place. The vinegar, 5.00 or 0.00 initially, 10.20 final volume, 10.20 trial 2, went to 23.50. We were looking for the 10 mils with our acid, our vinegar. Okay, what calculation 1? Calculation 1. So here's the list of all these calculations, okay? Let's just do them. Just get your numbers in our sample calculation table, showing your work for just a few items. I'll show you which ones. Because while I'm here, okay, calculation 2 is just what was the molarity of the base. And if you recall, this comes from lab 21. It was 0.50100 big M for the molarity of the base. Molarity of the base in experiment 21. Okay? Again, back to calculation 1. What are we supposed to do? We're supposed to get the volumes of the vinegar and the base. In other words, back to here, subtract. 18.30 minus 0. Our first base volume was 18.30. Our second base volume is 24.20. Volume of the vinegar started out at 10.20 was the first volume. Second volume was 13.30. Let's see how we get these values. Let's see how we get these values. Okay? Not interested in stopping at that mole box again. Am interested in calculating some molarities. So let me run you through trial 1. Trial 1. How did I get this molarity? Okay. As we know, what we do is we have our 4 boxes. In our 4 boxes, we had the base on the left, and now we have our vinegar, which is our acid, on the right. Okay. Peeking at those numbers again, just gotta hop back there. What was it? 18.30 for base. 10.20, okay, base 18.30 mLs, putting our info right in the box. The vinegar we said was 10.20 milliliters. We know the molarity of the base, 0.5100 moles per liter. And this is where we could stop, but let's not. Let's keep going. Let's calculate the moles of base. Now, cross the border to get the moles of the acid, the vinegar, and we go up and use our volume now to calculate our molarity. All right? One of the things. So that's going to give us a hint for where we start. But what we also need to do, according to our calculation list, okay, is balance the equation. Calculation number 4, why don't we do that right here? Let's balance that equation so we know what to do. HC2H3O2 plus some base would give us, I'm drawing the double arrows because it's a weak acid. Strong base, weak acid. And we would get our water, as we always do, and we get our sodium acetate. Right? When I go through, and you're going to put phases in, but when you balance, it's only the one hydrogen that ionizes. We notice everything else stays the same. it's a 1-to-1 mole ratio. So we're going to use that here. But how do we get started? Remembering that we start on the side of this box diagram that has two pieces of information. Again, what are we solving for over here? Moles per liter of the acid. We're looking for the molarity, which again, use the label. Moles per liter of HC2H3O2. Given, let's get this into liters right away. And so it's 0.018. Keep all your digits. They were measured. Liters of our base again. This was NaOH. Times our molarity conversion factor. Liters were in our given, so liters go in the bottom. The 0.51 sticks with the mole statement. Per 1 liter, this is NaOH. We're to moles. Let's cross the border right away. So remember, I need one calculation in this. So liters will cancel. Moles drop to the denominator, moles of base. And we will have moles of the acetic in the numerator. And again, it was 1-to-1. When I cross my labels, I see I'm almost there. I have moles. I just need to divide by my liters here in order to get my molarity of the acid. So, 0.0, and again that's liters, and that would be my moles per liter. That's where I got that number that you saw in the other chart, 0.91, I want to say 43 moles per liter. That number is what we now put in our calculation box. Oh, 9160. All right, that's the number that goes in my calculation box. What do we do next? Well, you're going to do it again. You're going to calculate that molarity again. For any other trials that you had, if you only had one trial, try using this data. See how yours comes out. Okay, once you do that, that's where you will put your average molarity, is in that line. Okay, average molarity of the vinegar. Now, what's the mass of 1 mole of HC2H3O2? Not rocket science. Let's add it up. Carbon, hydrogen, oxygen, and another hydrogen. When you go to your periodic table, that's going to be in this neighborhood of 30.02 grams. Error. Okay. Little error. What's the mass of C2? 24, and 16 times 2 would be 32, plus a few hydrogens. Fix that number there. That should be 60.00 grams. Okay. Now, what we're looking for next is the mass of acetic acid per liter of vinegar. Mass per liter of vinegar. So, how do we do that? Mass per liter of vinegar. Okay? So, this is really calculation 8. So this one I would like to see some work for. I would like, besides our box that we looked at earlier, let's see some work for this problem. And so what it wants here is grams of HC2H3O2. And what the problem reads, it says if you had 0.5 moles per 1 liter, and we want everyone to write this and do this first, so then you'll see how to do this with your numbers. C2H3O2, again, vinegar. Okay, and again, we want grams over liters. So all I need to do is take my answer to number 7, which was, what's that? 1 mole of HC2H3O2 is 60 grams. Okay, okay, our correction there, 60 grams. So they, using that molarity of vinegar, get 30 grams. That's what I was thinking, 30 grams per liter. Now, here's your job. Your job is to do the same calculations, okay, do that same calculation, but now use your molarity, your molarity. So we had on the previous, from our data table here, from the data table, we said 0.9160. So that's what I'm going to use, 9160 moles per liter, HC2H3O2, times that molar mass again. That number is still what we're using. And 1 mole of acetic. Moles will cancel. And I think when we crunched this number out, we had 54.9, okay, grams per liter. Right? So everybody take a minute and do yours. You may want to use your average that we had in this table. You may want to use that average molarity. You may want to use a different trial once you see what the value should be. Okay? But again, we do need this calculation once. All right, now what is calculation 9 asking? Calculation 9 says, do you understand here, and again this is what it read, so it's little teeny tiny here, but you can read it. If we assume our vinegar was like water, it looked like water, it's about the same density, 1 gram per mil. Then the mass, if I had a liter of vinegar, that would be 1,000 milliliters, and so that would be 1,000 grams. That's what that's saying. So this is what we are needing to do for number 9, is do this calculation. Take that mass you just calculated in number 8, divided by the grams of vinegar, 1,000 grams of vinegar, and multiply it by 100 to get our percent. Right? So doing that calculation here, so calculation 9, this is data from a 7th hour student, had 54.9 grams per liter of acetic acid. And what we want to do in calculation 9 is divide by 1,000 grams and multiply by 100 to get that percent. We can see this answer pretty quickly, 5.49%. Okay? Again, you need to do that. Do it with your average here, or do it with one of your other trials, because it's not our best data. Our next, okay, what you're interested in. So where do all these values go? Now I want these numbers in here. So again, this group had a 54.9 grams per liter, and that comes out to be 5.49%. All right? Here's what you should have had. When I go and look at a bottle of vinegar, those of you who had vinegar B, you were using Walmart's Great Value vinegar. And right on the bottle it says it's 5%. So you're going to, this was vinegar B, they're going to use 5.00 in their reflection and subtract 5.49 and calculate percent error. Those of you with vinegar A, okay, you were using Festival's Flavorite vinegar. I always use generic. And it was 5.1% vinegar. Vinegars are not all the same. And again, this is what we were able to calculate. So what else do you need to do in order to finish up lab 21 or 22? Reflection. Calculate, restate your purposes in the reflection. Calculate your percent error, vinegar A or vinegar B. And then if it's less than 10%, which we've had a lot of good numbers here, if it's less than 10%, you move on and give suggestions for improvement. If it's greater than 10%, I need some explanation. What went wrong? And once again, suggestions for improvement would include a discussion of what could be better in this lab. And again, would you also just jot down your thoughts and your reflections here? Is this a good way to learn about our how to write up a lab using the virtual rather than being here in class? Have a good day.